Hello, welcome to Calculus Lesson 40. Today we're going to talk about the units for the derivative, and then we're going to talk about how to find the normal or perpendicular line to a curve. So let's get started. The units on a derivative, remember that calculus isn't this narrow thing that we just do cool things with math and then move on. It's quite broad. It's applications, like if you've asked before when is math useful in real life, the answer is once you get to calculus. You can find changes in weather patterns. You can see how the economy is affected by different things. So many things are tied up in calculus. It's pretty cool, right? Because God's like fundamental to all of that, and God put it in place, and then there's a system that makes it. Anyways, it's just mind blowing. So when we ask, well, how is this useful in real life? Then we have to start talking about units and what the derivative actually means. So a couple of things you should know. We talk about position, velocity, and acceleration a lot in this class, and we'll talk about it more in physics. Position is often given in meters or feet. Velocity is usually given in whatever that unit is per time. So you can think of your car, right? It travels miles, but its velocity is miles per hour. And then you have that thing 0 to 60 time. How many seconds does it take to get to 60 miles per hour? So that would be acceleration, which is meters per second squared. It's meters per second, okay? So what's the relationship between these and calculus speak? Well, it's pretty simple. Position we usually call x, velocity we usually call v, which is the derivative of x. And acceleration we usually call a, which is the derivative of velocity, or it's the second derivative to position. So if they give us a problem like this, we can find the answer with appropriate units. The velocity of a particle in meters per second, so they tell us it's going to be, we're in meters per second right now, is given by the equation v equals 4t squared plus 2t plus 4, where t is time in seconds. What's the acceleration of the particle when t equals 3? So they want to know a at 3. In order to do that, I need to take the derivative of velocity because acceleration is the derivative of velocity. So acceleration at time t is the derivative of this, which is at plus 2. Then I'm going to plug in my time 3. Now up to this point, 26 would have been your answer. But because we're holding you accountable, and the AP will definitely hold you accountable to including units, you have to include the appropriate units. So anytime you take a derivative, you divide by whatever your independent variable is again. So if it's dy by dx, and you take the derivative, it's d squared y by dx squared. So you're dividing by x again. Here, we took the derivative with respect to time. So I have to divide by time again in my solution. So if this is in meters per second, then we're changing that per second. So it's meters per second, which is meters per second squared. Now, that's the kind of annoying part of our lesson. But the challenging part of our lesson today is finding the normal line to the curve. So we want to find the equation of the line normal to y equals e to the x at x equals 1. And I want the normal curve. So what does that mean? Well, the line tangent has the same slope. So we'll just have our little thought bubble over here. Tangent means same slope. Normal means perpendicular slope. So if I have some curve here, actually e to the x looks nothing like that. Goodbye, fake e to the x curve. So if I have e to the x here, and I look at x equals 1, this would be the tangent line. I'll draw it in green. And up to this point, that's what we've been finding already. But now they want the normal line, which is the perpendicular line that goes through that point. So how do we find it? Well, it's a lot like the tangent line. First step, we're going to find the slope. In this case, we're going to find the perpendicular slope. Then we're going to find a point, and then we're going to plug it into point slope. Simple enough. So what's the derivative of e to the x? Well, dy by dx, which is going to be our original slope, is still e to the x. I'll plug in my point 1, so it's e. So my perpendicular slope, remember the little upside down t, it means perpendicular. It means it's the negative reciprocal of my original slope. So my new slope is -1/e. Bothered? Don't be. How do I find a point? Well, I have the x value, but I don't have the y value. But I know that y equals e to the x. So y equals e to the 1. So my point is 1e. Because y equals e at x equals 1. Finally, I'm going to plug it into point slope. We remember that's y minus y1, which is e, equals m x minus x1. And that's the equation of the normal line at the point x equals 1. Simple as that. Finally, there's a little bit in your lesson about maximums and minimums on a graphing calculator. I'll show you how to do that in person. So that is lesson 40.